Hello everyone. In this video, we will be learning what displacement volume of an engine is, also known as the swept volume. So many cars these days have small badges on their trunk or hatch that may say 2.0 liter or 1.5 liter, or some big muscle cars like Mustangs have badges on their fenders saying 5.8 liter or 6.0 liters. In this video, we will be learning exactly what that means. Over here on the left, I have a very simple schematic diagram of a cylinder, piston, and crankshaft. If you look, there are these dotted lines on the top and on the bottom. These represent the top dead center and the bottom dead center of the piston, which means that at these points, the top of the piston is either at the maximum bottom position or maximum top position as the crankshaft completes the cycle. And the volume in between the top dead center and the bottom dead center is the displacement volume. On the right hand side, I have the schematic diagram of top dead center and bottom dead center in 3D, in 3D. As you can see, the distance between the TDC, the top dead center, and the bottom dead center is known as the stroke length, denoted by capital S. And the diameter of the cylinder or piston is known as the bore, denoted by B, capital B. The displacement volume is the volume between these top dead center and the bottom dead center points, which can be calculated using the equation V sub D, so V sub D equals to parentheses pi over 4 times bore squared times the stroke. So this is the displacement volume for one cylinder. However, if you want to calculate the volume for the entire engine, like some cars have 6 cylinders, some have 4, some have 8. To calculate that, you just multiply by the number of cylinders. So NC times the rest of the equation is exactly the same. So pi over 4 B squared times the stroke. Another thing that I wanted to mention is that there are 3 types of dimensions of stroke and bore. The first diagram is known as square, where the stroke length and the bore length are the same. The second diagram in the middle is known as undersquare, where stroke length is longer than the bore length. And the third diagram over here is known as oversquare, where the stroke length is smaller than the bore. The modern car engines are usually near square. These different dimensions have different effects on the performance of an engine, which will be discussed in another video. Next, I wanted to show you guys a very basic calculation of the displacement volume of a car engine. So here I have taken a screenshot from the Honda's website from their 2022 Honda Civic engine specification page. We have 5 different types of Civics here. The LX, the EX, Sports, and Touring, and Honda Civic SI. So the LX, EX, and Sport is the same engine. And the Touring and SI is the same engine as far as the engine displacement volume is concerned. So here I will be showing solving the displacement volume of 2.0 liter Civic. So that will be the first 3. Sorry about that. Using the same equation that I mentioned above. So the equation goes, so V D NC, which is the number of cylinders, times pi over 4 times bore square times the stroke length. So VD again times this is Honda Civics are 4 cylinders, so we will write 4 here times pi over 4 times the bore length. So bore length is given over here. So that will be 86. So 86 millimeters. So write 86 millimeters. I'm writing these units because I wanted to show you what the final units turn out to be. And the stroke is 85.9. 85.9 millimeters. Now let's do the calculations. So 4 times pi divided by 4 is 3.14159. So 16 rounded up. Which makes sense because you can just cancel these 4s and you just write the value of pi, which is 3.1416. Next, 86 squared. So that will be 7396 millimeters squared. Not millimeters anymore. This is millimeters squared. And 85.9 millimeter, we'll just write it as is. Okay, now let's multiply all of this. 3.1416 times 7396 times 85.9. This turns out to be a very big value, but this is in millimeters, so this will be big. So 1.995910 millimeters cubed this time, because we have another millimeter over here. So we have 2 millimeter square and plus another millimeter, which will be millimeter cube. Now this is in millimeter cube, but what we usually find on the cars or on their websites is in liters. The value is in liters. So in order to convert millimeter cubes into liters, we just simply divide this millimeter by 1 million. So if we just divide this by 1 million, that will also be millimeter cube. So millimeter cube cancels out. This 10000. Okay, so this is 1.959 liters, which is very close to their car 2 liters. The value that they gave in 2 liters. So because they just rounded off, so I guess I haven't rounded it off, so they rounded off, so that's why there is 2.0 liter and mine is 1.959 liter, which is super close, so don't need to round that off, I guess. Actually, you know what, let me just round it off. So this is 2.0 liters, so which is exactly the same as this. And there goes the displacement volume calculation. Another thing before I end this video, I just want to really quickly mention that you see in the past slide we talked about, previous slide we talked about the or square, under square, and over square. So this right here, you see bore is very close to the stroke. So it's just 0.1 off. The stroke is 0.1 off. So that this is very close. So this is near square engine. However, if you look at this Touring and Honda Civic Si, that for the bore for that is quite a bit smaller than the stroke, right? So this is under square. Both of these are under square. And those ones, these three are almost square, so near square, so we'll just write square because they're very close, and that 0.1 is negligible at this point. So that's it for this video. If you're confused about something, if you have any question, please let me know in the comments. And thank you for watching. Cheers.